Alright, so I said there was one instance when your inequality is going to flip the side, and that happens only when you are dividing by a negative. So if this was just 9x is greater than or equal to 27, it wouldn't change. If this was x minus 9, it wouldn't change. If it was x plus 9, it wouldn't change. If we had x over negative 9, it would not change. Only when we are dividing by a negative is your inequality going to flip, and I will tell you why. So if we solve this out, to get x alone right now, we know x is being multiplied by negative 9. So we're going to need to divide both of these sides. I don't need tape anymore. We're going to need to divide both of these sides by negative 9. And in order to have our sides, we do need to draw our line down the middle. Sorry, I forgot that. All right, so this side is going to have 27 divided by 9 is negative 3. And this side, we are left with x. So what changes is when we started, let me move this line so you guys can see it a little bit better. When we started, x was greater than or less than, or negative 9x was greater than or less than 27. So our answer, we are going to flip that inequality around. And now x is less than a number or greater, less than or equal to negative 3. And the reason that flips around is let's plug in some of those solutions. So if we go ahead and graph this on our equality, we know it is less than or equal to negative 3, so our circle is going to be filled in. I always just use black. When you guys draw these out, you would just circle it in instead of leaving it as a whole. And since it is less than, we are going to move over to the left. All right, so the reason that inequality needs to flip around is part of that check step. So remember when we talked about one-step equations, we can always check our work to see if it is true. So this number line shows us what our possible answers are. We know it's negative 3 is a possible solution. We know that negative 4 all the way up till negative 10 is a solution. So what if I plugged in negative 5 as a solution here? So if I had negative 9 times negative 5 is greater than or equal to 27. Negative 9 times negative 5 gives us positive 45. Is greater than or equal to 27. Is that a true statement? We would hopefully say yeah. So that is why your inequality needs to flip. When you divide by a negative, you have to flip your inequality. If it's greater than, you need to make it less than. If it's less than, you need to make it greater than. Because when you plug in your solutions after you flip that, your answers become true. If this inequality, if we flipped it to the other side, let's say that I didn't have it be less than. I had all numbers greater than, so I would move this to the right, making positive 5 an answer. Positive 5 times negative 9 is negative 45. Negative 45 is not greater than 27. It's less than. So that is why we need to flip it, because it makes your answer true, and we use our check step in order to prove that. So this only, again, sorry, I forgot to do an arrow, only works when you are dividing by a negative number. If you're dividing by a positive number, you don't need to use it. If you are subtracting, you don't need to use it. If we are multiplying, you don't need to use it. Only when you are dividing x by a negative number do we need to end up flipping on our inequality. And otherwise, 100% of the other time, you just leave it as it is. If it starts with greater than, it ends with greater than. If it starts with equal to or less than, it ends at less than. So that's really the only tricky part with these inequalities, is just when you're dividing a negative, you end up flipping your inequalities. So there's, I think, 2 to practice after this. And then there's one last video for you to watch on how to complete the slides and some extra practice and kind of what your week is going to look like.